Supernovae are the most powerful explosions in the universe, releasing energy that can outshine entire galaxies easily. To understand their scale, we have no real metaphor on Earth that can truly capture this cosmic power.
If our sun became a supernova, it would feel like a nuclear blast hitting you every single second.
This intense radiation would continue for weeks, stripping away everything we know about our peaceful existence on Earth. While they are engines of creation, forging life-enabling elements, they also burn sterile holes through entire galaxies. So, what would happen if one hit Earth? The answer depends entirely on the distance of the explosion. There are two main ways to create these events. Either the core of a massive star suddenly implodes, or a white dwarf gains too much mass, eventually igniting a runaway chain of explosive nuclear fusion. Regardless of the cause, the outcome is the same: a supernova explosion that reshapes the surrounding space.
Earthly explosions happen fast and end quickly, but a supernova is a long-term geological and cosmic event.
It is more like a volcanic eruption followed by a massive tsunami that lasts for many thousands of years.
At first, there is a colorful ball of hot gas, creating a cloud that shines for a month. But then, it doesn't stop. Hot and dangerous gas rushes outward at 10,000 kilometers per second. This wall of gas expands for tens of thousands of years, spanning dozens of light years across space. Eventually, it cools off and disperses its heavy elements back into the galaxy to form new star systems. So what if this star tsunami hits us? The level of damage depends on the distance.
Humans have witnessed many supernovae from thousands of light years away. They appear as beautiful new stars.
Some outshone the moon, twinkling for a few weeks before disappearing forever into the night sky.
Aside from looking very pretty, these distant explosions don't do much harm to our planet at all.
Things get a bit more intense when a supernova occurs around 300 light-years away from us. We can expect one this close every few million years, giving the night sky an eerie glow. While it is dim enough not to harm us directly, it can still affect the Earth's environment.
It's like being hit by the last weak waves of a tsunami. Noticeable, but not destructive yet.
We can expect one this close every few million years, giving the night sky an eerie glow. These explosions cleared a 1,000 light-year wide pocket of space called the local bubble, where we live now.
They blew away gas and dust, creating a cradle for new star formation that surrounds our system. At 150 light-years, we approach the zone where real, tangible damage begins to occur. At 150 light-years, we approach the zone where real, tangible damage begins to occur. This magnetic energy is woven through the shockwave, accelerating particles to immense speeds across the galaxy. It acts like a giant particle accelerator, shooting deadly radiation in all directions for many centuries. Waves of these cosmic rays would wash over us for thousands of years, long after the light fades. While our atmosphere protects us, the influx of radiation would still increase cancer and mutation rates significantly. It wouldn't cause a mass extinction, but the biological impact would be very noticeable for generations. Spaceflight would become impossible, as astronauts couldn't survive the intense radiation levels outside our atmosphere. A supernova this close could trap our species on Earth for thousands of years, halting our progress.
Within 100 light-years, things get bad. The supernova disrupts our climate in unpredictable ways.
First come the photons, then decades of radiation. Both seriously damage the ozone layer, our primary shield. The ozone layer normally absorbs UV radiation by breaking apart and reforming in a continuous cycle.
But supernova radiation creates nitrogen oxides that steal the oxygen, quickly depleting our protective ozone layer.
Without this shield, everyone on the surface is exposed to lethal levels of UV radiation from our sun.
Cancer rates would skyrocket, and just going outside during the day could be life-threatening for everyone. The radiation would also kill the plankton in the oceans, which are the base of the food chain. This would lead to a mass extinction event, starting for the oceans and moving to the land. Supernova radiation would also ionize gas in the atmosphere, knocking electrons off nuclei and leaving them charged. These charged nuclei act as seeds for water vapor, forming massive, global clouds that block the sun. In the worst case, they would reflect enough sunlight to trigger a new, global ice age. An ice age 2 million years ago might have been caused by a supernova hitting our system.
Some think a supernova caused the Devonian mass extinction 350 million years ago.
The radiation also causes enormous electric avalanches, creating the worst thunderstorms in millions of years. Intense lightning would cause global wildfires, destroying forests, crops, and our entire electrical grid. Nations would struggle with food shortages and chaos. Modern civilization might not survive a hit like this. A supernova this close would do significant damage for thousands of years, ending our modern way of life. While humanity might survive in bunkers, the world they return to would be hostile and devastated. Extinction is a real possibility at this range, as the Earth's ecosystem completely collapses. At 25 light-years, we are in the kill radius. A mass extinction is almost guaranteed.
Half of the ozone layer would be destroyed instantly, and massive climatic disruption would ravage the planet.
Entire ecosystems would be wiped out by radiation as global wildfires envelop the entire planet quickly. The same disasters from before happen, but much more intensely and much faster than we can adapt. At 4 light-years, the distance to Alpha Centauri, the effects would be truly extreme for Earth.
The supernova would be almost as bright as our own sun in the sky for weeks.
Within days, the Earth's surface would get as hot as a sauna, baking for many weeks.
The surface of the Earth burns, scoured of all life. Even the oceans are not safe. It would be the largest extinction in history, killing everything that sees even a hint of sunlight.
Life basically has to start over from the deep sea and the deep soil survivors.
So, should you worry? The short answer is no, not in our current lifetime. Fortunately, there are only a handful of stars that may explode within 1,000 light-years. None of them are close enough to be a serious threat to our planet's survival. These stars will probably not go supernova for many millions of years from today. So for now, you are safe. But the far future holds no absolute guarantees.
As stars orbit the galaxy, our descendants may find themselves dangerously close to an explosion.
By then, a more advanced and wiser humanity will hopefully be able to just move away. They will have the technology to protect themselves from even the most powerful cosmic events. In any case, you can sleep well tonight under the beautiful, peaceful night sky.
The universe is vast and dangerous. But for now,